Hello, my name is Joe Barth, team captain of South. I would like all watching and have me talk about my proof of concept Guardian Drone Angel for the Neudesic IoT Innovation Challenge. Here's the submission for Micro Challenge 3. I would like just to thank Ross Harrison and the crew that set this challenge up because it's it proved to be very fun, but then also challenging and then also rewarding. I've learned so much about IoT, how to code a Raspberry Pi, how to work with Azure and IoT devices, and then also I get to learn how to fly a drone. But that's not the full reason. Let's talk about the full implementation. So we have Cortana channel. We start up an Azure bot. You write to the SQL database the command, and then the Raspberry take the commands every couple of seconds and the drone to fly up or fly down or use a certain map like what we talked, like a map A using GPS coordinates or map B, hub telemetry data. So all this at the drone that we can use to hopefully predict something or do something with it. But I kind of wanted to show you first before we do get into the prediction stuff. This is the Cortana channel, and this is what you do to you start it up, and it takes off, and then you command it to land. Cool thing about the implementation and what entails is that you have the ability to connect to Power BI to see the data in real time using streaming analytics. The IoT Hub takes the telemetry data, as we showed you in the diagram, that it sends it to the IoT Hub, and that can be streamed either to Power BI or it can go to Azure Data Analytics Store. We can show the current current drone battery we have for the data that's in real time and look at it, and it's moving at a windowing pace. So it's really cool implementation for that, and that remind you have that ability to do all this. So if we look at where we were when we first started, now we're moving toward assisting. We're taking everything and putting it together, all these micro challenges, and we wanted to be able to assist well with Guardian Drone Angel. In order to make informed decisions, we use machine learning. We train a model. We take the data that's given to us, and we make informed decisions on that. So reviewing data and sensing, we use facial recognition from the Face API to recognize somebody and take action. Intelligence, we took a Q&A bot, an Azure bot that makes decisions based on a knowledge base. We did that. And then in the final implementation, a little Azure ML, which in the new Azure SQL DB 3 or 4 weeks ago, so we are on the bleeding edge right now. We're using a predictive model, a predict function within SQL Server on an Azure SQL DB, decisions based on other IoT devices. So really, it's coming into this where we're using all these other IoT devices to make decisions to go on and control. We do that through connecting through Raspberry Pi using Azure functions, and now we use machine learning. Let's go ahead and show you a little bit. If we go ahead and look what we're doing here, we needed to generate, drones within the Seattle area, which is crazy. It's writing out updates, about 4,730 updates per second, and that's what we can do with the power of Azure. You can scale up and scale down as needed. We have a premium level, which cost us $10 an hour, which comes out to be about $7,000. You can have it continually running and using in-memory technologies to get the fastest and latest and greatest of the data. In streaming analytics live, you have to have it refreshed, but it is pretty near real time. And you're using the latest in-memory technologies to be able to. We're not going to focus on that, but you now have the availability, now that we have rating, what we wanted to do was prove out that we can make an informed decision on which map to use, as we did with our Q&A knowledge bot before. So if we have map A and or map B taken, all these drones are running those maps, right? And constantly, and we're using a random generator right now to decide how long the drone's going to take. Are running those maps right now. And what is happening is then we take and we're able to push it into a model. So we have a couple factors that we had, you know, battery level and altitude. That would determine, based on that, we'd determine how long it was we're gonna predict the time taken for the next run of the drone we want to use. And so that's used in R to create a model, and then we train the model, and then we use that to predict function within Azure SQL DB Premium. You want to be able to do that, and we are running that constantly. And what is happening, we're using an Azure function to do that within. And so now, if we look, map 1, which is map A, is the fastest map to use. So we can programmatically say, drone, go ahead and pass the map. So you can time the drone, say the drone can do this all on its own autonomously and make decisions in, using the cloud, using Azure SQL DB. If we look at the actual function, it's every 30, I think it's every 30 seconds or a minute. It runs, and it doesn't click there. It calls, it actually truncates that table or result table, and then and run the model that we want to. And it's doing it all on its own. It's really cool implementation. This isn't just for drones. This is for any IoT, any device data that you want to push into data lake, Azure Data Analytics, using Azure SQL DB Insight. You can use any of these. I used Azure SQL DB because you can do machine learning on it now, and it's much more cost effective. But you can use anything within the Azure or cloud framework to do this. Solution made decisions based on other IoT devices, and that's what I think the analytics platforms for enterprise AI is all about, and focus on going forward. Great project to be able to actually move this into what we're future, and it was awesome. Thank you for giving the ability to do this. I appreciate it, and rest of your week. Thank you.